Welcome YouTubers to another episode in my Grammar Hero series. In this video, I'm going to discuss the geometric formulas you need to know in order to do your best on the Armed Services Vocational Aptitude Battery. Before I do that, however, I just want to take a few minutes to discuss the ASVAB itself. First, I want to point out that the ASVAB is a computer adaptive test for which you'll have 154 minutes, as you can see right here, to complete 145 questions. In addition to receiving a score for each of the ASVAB's 10 different subtests, you'll also receive what's called an AFQT score, and of course AFQT stands for Armed Forces Qualification Test. This is the score that says you're either qualified to join the military or not qualified to join the military. As you can see, that score is broken down into two different ways. It's broken down into categories, which range from 1 to 5, as well as ranges based on percentiles, and those range, of course, from 99 to 1. So, for example, if you score a 50 in terms of your AFQT score, that means you've scored better than 50% of all the test takers, and at the same time, that would put you in corresponding category 3A. As a rule of thumb, you want to score somewhere in category 3B or better. That is, you want to score somewhere between 31 and 99. Now, you may be saying to yourself, how is the AFQT score calculated? Because you may not know a lot about automobiles. Fortunately enough, the AFQT score is calculated based only on your performance on 4 subtests, particularly arithmetic reasoning, word knowledge, paragraph comprehension, and mathematics knowledge. Okay? So my advice to anyone who's preparing for the ASVAB is this: focus the majority of your studying efforts on these 4 subtests, and in so doing, you should not only obtain a good AFQT score, you should also qualify for most jobs in the military. Okay? So today's video is about geometric formulas. They're going to be in regard to, today's video should help you do well on the mathematics knowledge section as well as the arithmetic reasoning section. If I'm not mistaken, I already have 6 videos up for arithmetic reasoning. I also have 6 videos up for mathematics knowledge, and I have 1 video up for word knowledge. Before I forget, let me just say this. If you find my videos helpful, please consider subscribing to my channel. That way I can monetize these videos. And in addition, if you have any suggestions, go ahead and leave some feedback in the comments section below. Okay? Continuing with this video, I just want to say this. The hardest part of the ASVAB is the fact that you have to work out math problems by hand and from memory. So when I say you need to know these geometric formulas, you have to know them. You have to look at a problem and decide, are you using the circumference formula or the area formula for the problem? So again, there's only 11 of them. Most of them, as you'll see in just a few minutes, you already know. So just focus in that case on the ones that you don't know yet. Okay? And again, I want to stress this: there are no formula sheets or calculators allowed on the ASVAB, so you have to get comfortable doing addition, subtraction, multiplication, and division with decimals and fractions. If you need help with long division or fractions, take a look on my YouTube channel. Right now I have 2 videos up, one of which is in regard to doing long division, including with decimals, and I have an entire, I think it's 40-minute video on how to deal with fractions. Okay? So let's go ahead and get started. And just one more housekeeping item I want to mention before we get started. This video is broken down into 2 parts. In the first part, I'm going to discuss the formulas themselves and give you some very basic examples of how to use them. In the second part of this video, I actually created 20 sample problems which mirror the problems that show up on the ASVAB usually. And as you'll see, those problems are fairly difficult to do. So if you need to use this formula sheet as you work on the second half of this video, by all means go ahead and use it. Just bear in mind that the more problems you can do without this formula sheet, the better you're going to do on the ASVAB on test day. Okay? So let's go ahead and talk about the first formula, namely area of a circle. So to find the area of the circle, you use this formula. Area equals pi r squared. That is pi times r squared, where pi is always going to be 3.14, and r simply refers to the radius. Again, in light of the fact you're doing everything by hand, you're always going to make pi 3.14. So let's go ahead and talk about how to find the area and what it is specifically. So if I drew a circle and asked you to find what the face of it was, we would be talking about area. Okay? So let's go ahead and do a very basic example. So I'm going to give you this circle with a radius of 2. And again, the radius, as you can see to the right here, is simply from the edge of the circle to the middle of the circle, whereas the diameter spans the full length of the circle. Okay? As it happens, the diameter is twice as long as the radius. So in other words, if I said the radius was 2, you would know the diameter would be 4. That's twice the radius. If I said the radius was 10, you know the diameter would be 20. And if I said the radius was 100, you would know the diameter would be 200. Again, diameter is always twice as long as the radius. So getting back to this example, I gave you a radius of 2, and I asked you to find the area. So I'm just going to, first thing I'm going to do is jot down the formula to make sure I'm using it right. Area equals pi r squared. Now, I always like to work vertically, and as you get into higher level math classes, you always want to keep your equal sign in a straight line as best you can, because this helps you keep your work organized. Okay? So try to think about organizing your work as you're working on these practice problems. So pi, I know pi is going to always be 3.14 since I'm working these problems out by hand. Radius is this distance, which I said was 2, and I know that 2 is going to be squared. Let's keep working it out. Area equals 3.14. 2 squared is the same as 2 times 2, which is going to be 4. So now this problem is the area equals pi times r squared, which is 4. So we got to go ahead and work this out. Again, hardest parts working with decimals and fractions, including for problems that require you to do multiplication and division. So let's talk about how we're going to do 3.14 times 4 by hand. If you haven't done it in a while, this may look foreign to you and you might pause right here. So let's write 3.14 right here. We're going to multiply that by 4. So the way you multiply decimals and whole numbers is like this. You take this decimal, you move it twice to the right, which will make this 3.14 into 314. Let me write that off to the side so it's clear. And we're going to multiply 314 by 4, and at the end I'll take these two decimal places that I moved to the right back into the left. So let's go ahead and do that. 4 times 4 is 16. Carry the 1. 1 times 4 is 4. Plus 1 is 5. 3 times 4 is 12. Okay, this is too big of a number. Oh, we got to move our two decimal places back in. 1, 2. So we know our area is simply going to be 12.56. Okay. So let's talk about the circumference now. For the circumference, there's two formulas you can use to find it. And as I did right here, I just want to point out that imagine you start walking right here at this x, and you walked in a full circle back to where you started. Their circumference, unlike the area, is the distance around the edge of the circle, and that's why it's called the circumference or the perimeter of the circle. There are two formulas you can use to find the circumference of circles. You can either use 2 times pi times the radius, or you can do pi times the diameter. So let's say, and let's use this circle again. I'll just make it a little bigger so it's easier to see. Let's say I gave you this circle again, and I said the radius was 2, and I asked you to find the circumference. So again, we're just going to fill in what we know for these for this formula. Circumference equals 2. Again, you're just dropping that down as part of the formula. Pi times 3.14 times the radius, which is 2. Okay, and let me write that over here so it's more clear. 2 times pi times 2. Okay, let's go ahead and get this formula going. Circumference equals pi. What's the diameter? The diameter is always twice the radius. So again, you could just draw a straight line here and make this 2. 2 plus 2 is going to be 4 for the diameter. So this one is circumference equals pi times 4. Let's go ahead and work this one out. Circumference equals, again, for pi, we're always using 3.14 times 4. Circumference, what I do over here, I did 3.1 times 4. So I already did the work here. I know this is going to be 12.56. Let's work this one out. This is 2 times pi times 2. I'm going to combine these. I'm going to do 2 times 2, which is going to be 4. And I still have this pi, which I know is 3.14. Take a look. I did 4 times 3.14 here too. So I know the circumference is going to be 12.56. Okay? It's your choice, in all honesty, as to which of these you use. But you do have to know that these are equivalent. And if you're only given the diameter, you can use this formula. If you're only given the circumference, you can use this formula. Okay? So now that we've discussed circles, let's go ahead and talk about squares. Fortunately enough, most people are pretty comfortable with squares, so I'm going to move pretty quickly through this section. You need to know how to find the perimeter and area of squares. To find the perimeter, you simply add up all the sides, and the formula for that is perimeter equals a plus a plus a plus a, where a is one side of the square, or similarly, perimeter equals 4 times a, that is 4 times one of the sides of the square. So if I let this side equal 4, again, in squares, all the sides are equivalent. So if this is 4, this is 4, that's 4, and that's 4. So let's go ahead and find the perimeter of a square whose sides are 4. We got 4 plus 4 plus 4 plus 4. 4 plus 4 is 8, plus 4 is 12, plus 4 is 16. Okay? The area of a square is simply side times side, or one side squared. So let's go ahead and find the area here. Side times side, which is going to be 4 times 4, which is 16. Okay? Let's talk about rectangles, and again, in light of the fact most people know how to deal with rectangles already, I'm just going to touch on this very quickly. To find the perimeter of a rectangle, it's very similar to how you found the perimeter of a square. You simply add up all the sides, but unlike in a square, these two sides are equivalent, whereas these two sides are equivalent. Okay? That is, the widths are the same and the lengths are the same, but the width does not equal the length. Okay? Find the perimeter. The formula is a plus b plus b. That is, you add up all the sides, so perimeter equals, Let's say I let the width be 10. I know if this length is 10, I said width, this is length. If this length is 10, this length is 10, this width is 5, and this width is 5. So let's add those all up. Again, A plus A, or side plus side, 5 plus 5, plus length times plus width, plus 10 plus 10. 10 plus 10 is 20, plus 5 is 25, plus 5 is 30. Okay, and here's the other representation of that formula. I'm not concerned about this. As long as you know to add up all the sides, you should be fine. To find the area of a rectangle, you do length times width, or A times B, depending on how you set up your rectangle. So to find the area of this rectangle, I'm going to do 10 times 5, which is 50. Okay? Now, let's talk about cubes. A cube is just a three-dimensional square. So all these sides, every single side in a cube is equivalent. And notice I didn't include surface area. As far as cubes go, you just need to know how to find the volume. And to do that, you take one of its sides and multiply it. You multiply the width of the square times the height of the square, or the width of the cube times the height of the cube times the length of the cube, or one side cubed. So if I let this side equal 3, I know if I let this length equal 3, the height would be 3, and the width would be 3, and according to the volume formula, it would be 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. Okay? A rectangular prism is just like a cube, except its length, its height, and width more often than not are different. So to find the volume of a rectangular prism, you do length times width times height. And so let's say I let the length equal 2, the height equal 3, and the width equal 1. We would just plug those into the volume formula. Volume equals length. Length is 2. Width is 1. And the height is 3. 2 times 1 is 2. Times 3 is 6. Okay, again, I'm not concerned about cubes or rectangular prisms. You guys probably know those pretty well. And so let's talk about triangles. As far as triangles go, you need to know two things about them. You need to know how to find the area of them, and you need to know how to use the Pythagorean theorem. So the area of all triangles is 1/2 equals base times height. And in this picture, which I chose because I like it, this is a right triangle. You can see the base is here. This is a not a right triangle. You can see this is the base, and this is the height. This is an obtuse triangle, and you can see that this is the base, and this is the height. Okay? So depending on the type of triangle, you have to be mindful of what your base and heights are. More often than not, you're going to be given triangles that look like this, in which case this is your base and this is the height. So again, the formula is simple. Area equals 1/2 base times height. So if I gave you this triangle right here, and then we're going to make it a right triangle. If I gave it a base of 3 and a height of 6, to find the area, we would do area equals 1/2. Base is 3, height is 6. Okay? Area equals 1/2. 3 times 6 is 18. Area equals 1/2 of 18 is 9. Okay? Pythagorean theorem. The Pythagorean theorem is how you find missing legs of right triangles. And I just want to point this out. A and B are the legs, and it doesn't matter how you set those, but the hypotenuse, which is right here represented as C, is always directly across from the right angle. Okay? So as you work these problems out, it doesn't matter what you let A be or B be, your hypotenuse C in this formula must always be directly across from the right angle. Okay? So here's the formula. A squared plus B squared equals C squared. And let's say we're trying to find the hypotenuse, C. And I told you one leg was 3 and the other leg was 4. Again, it does not matter how you put these on the triangle, as long as the hypotenuse C is directly across from the right angle. So I can let this be 4 and this be 3, or if I really wanted to, I can let this be 3 and this be 4, but this must always be C because it's across from the right angle. So again, we're trying to find the length of the hypotenuse. So let's go ahead and start plugging things into the formula, and I'm going to do that over here. Again, we're working with A squared plus B squared equals C squared. We don't know what C is, so let's let A equal 4, and we'll let B equal 3. So this is going to be 4 squared plus 3 squared equals C squared. 4 squared is 16. 3 squared is 9 equals C squared. 16 plus 9 is 25 equals C squared. And again, I'm trying to keep my equal sign in a vertical line as best I can. To solve for C now, to get rid of this square, we have to take the square root of both sides. This square root gets rid of this square, so we're left with C equals the square root of 25, and C equals the square root of 25, which is just 5. So in this case, C would be 5. Okay. So you do need to know the Pythagorean theorem. And the final formula you need to know is how to find the sum of interior angles of polygons. And that's via this formula. Namely, the sum of the interior angles is 180 degrees times n minus 2, where n is the number of sides the polygon has. So here are some common shapes. We have a triangle. A triangle has 1, 2, 3 sides. So let's go ahead and plug that in our formula. 180 degrees. Again, n is the number of sides. 1, 2, 3. Minus 2. Let's work this out. 180 degrees. 3 minus 2 is just 1. Anything times 1 is always itself, so 180 times 1 is just 180. So the sum of the interior angles in a triangle is 180 degrees. Let's try this one. Looks interesting. Let me count the sides first. 1, 2, 3, 4, 5, 6, 7, 8 sides. So we know this is a octagon. Let's plug it in the formula, and we're trying to find the sum of these interior angles. So S equals 180 degrees times n, number of sides, which is 8 minus 2. S equals 180. 8 minus 2 is 6. Let's work this off to the side. 0 times 6 is 0. 4 times 6 is, or 8 times 6 is going to be, see if my math's on today, 48. Carry the 4. 6 times 1 is 6, plus 4 is 10. So we know there are 1080 degrees for the sum of the interior angles of a octagon. So that's all I have for formulas that you need to know as far as geometry goes. In the future, I'm going to post a video for the algebra formulas you need to know. And if you take a look at my YouTube channel, you're going to see that I already have videos of how to deal with fractions as well as long division. So if you need help with those two topics, take a look at those videos. But at this point, I'm going to go ahead and start working on some sample problems. Again, they're much more difficult than the ones I worked out for you, just to give you an idea as to how to use these formulas. At this point, if you want to use the formula sheet as I work out those problems and you attempt to work them out too, go ahead, but at some point you need to stop using this formula sheet. You just need to devote these formulas to memory. So on that note, let's go ahead and take a look at some practice problems. Number 2, certain type of siding for a house costs $10.50 per square yard. What does it cost for the siding for a wall 4 yards wide and 60 feet long? Okay, so we're told the cost per square yard. We want to know what it costs for a wall that's 4 yards wide by 60 feet long. Well, you can't do this problem as it stands because we have something in yards, we have something in yards, and we have something in feet. So before we push forward, we need to convert either yards to feet or feet to yards. In this case, we have yards here, and feet here. So I'm going to make this 60 feet. I'm going to convert it into yards. Of course, we should know there are 3 feet in every yard. So what I'm going to do right out the gate is do 60 divided by 3. 60 divided by 3, of course, is 20. So instead of what is the cost for siding for a wall of 4 yards by 60 feet, this is 4 yards by 20 yards. Okay, now we're trying to find the area of a rectangle that's 4 feet wide and 20 yards long. 4 yards wide, 20 yards long. Sorry, I said feet there. To find the area of a rectangle, we do length times width, which is, let me write that out for you before I do it, length times width. In this case, that's 20 times 4, or 80. Okay, now we take this 80 and multiply it by our cost per yard, and we'll come up with our answer. So this is going to be 1050 times 80. And again, since we're multiplying a decimal, I'm going to move this 2 decimal places. So it becomes 1050, and I'll add the 2 decimal places back at the end. 0 times 0 is 0, 0 times 5 is 0, 0 times 0 is 0, 0 times 1 is 0. Bring down a 0 since we're starting this number. 8 times 0 is 0, 8 times 5 is 40, carrier 4. 8 times 0 is 0 plus 4 is 4. 8 times 1 is 8. Add. 0 plus 0 is 0. And we can see this is going to be just 8, 4. And I'm writing off to the side so I don't mess up the next problem. 8, 4, 0, 0, 0. Add our 2 decimals back in. 1, 2. And we can see that this is going to be $840. Okay? Again, the trick there was to convert feet to yards and then find the area accordingly and multiply that by the cost per yard, square yard. The total length of fencing needed to enclose a rectangular area 46 feet by 34 feet is, we can see we're given everything in feet, but the answers are in yards. So in this case, we're going to have to make a conversion, but first let's sketch it out. Told it's a rectangle that is 46 by 34 feet. and we want to know the total length of fencing to enclose this rectangle. Again, if I was interested in covering the face of the rectangle, I'd be using area. Since I want to know the distance of, or the length of fencing, I'm going to use perimeter. And perimeter of a rectangle or anything is to add up all the sides. So I'm going to do 46 plus 46 plus 34 plus 34. Add that up. 6 plus 4 is 10. 6 plus 4 is 10, so I know this is going to be 20. Carry the 2. 4 plus 3 is 7. 4 plus 3 is 7. 7 plus 7 is 14. Plus 2 is 16. So I know the perimeter of fencing I need in terms of feet is 160. That said, I have to divide 60 divided by 3 to get my yardage. Again, there are 3 feet in every 1 yard. So we'll do 160 divided by 3 to get our yardage. 3 doesn't go into 1. 3 goes into 16 5 times. 3 times 5, of course, is 15. 16 minus 15 is 1. Drop down this 0. 3 goes into 10 3 times. And right away, we know what our answer is going to be. It's not going to be 26. It's not going to be 52. It's going to be 53 and a third, but let's confirm that. 3 times 3 is 9. 10 minus 9 is 1. Bring down a 0 to start a new to make it divisible. 3 goes into 10. Let's see. Oh, we would actually be done since we're working with fractions. This 10 minus 9 would be 1, which would be your remainder that you would put over the divisor. So this would be 53 and 1/3. Again, this would be our remainder. We put that over the divisor, so this becomes 53 and 1/3. And again, let me give you another example of that because that was a little unclear. Let's say we had 13 divided by 4, and I wanted you to convert this to a mixed fraction, a mixed number like this. You would say 4 goes into 13 3 times. 4 times 3 is 12. Subtract. 13 minus 12 is 1. So you would take this remainder of 1, put it over 4 to make this a fraction of a mixed number of 3 and 1/4. Again, here's our 3 that we got using long division. We had a remainder of 1. We put that over the divisor to get a mixed number of 3 and 1/4. That's all you do when you're converting long division to mixed numbers. And I actually have a video of this under Mastering Fractions for the Test of Adult Basic Education. That is the TABE test. If you struggle with fractions, go ahead and watch that video. It should help clear everything up in terms of fractions. Alright, number 22. The area of a room measuring 12 by 15 feet is 9 square yards, 12 square yards, 15 square yards, 20 square yards. Again, we're going from feet to yards, so we got to make a conversion at some point. Again, there are 3 feet in every yard. So since these numbers are both divisible by 3, I'm going to divide them right off the bat. 12 feet is the same as 12 divided by 3, or 4 yards. 15 is the same as 15 divided by 3, or 5 yards. Now this problem is the area of a room that's 5 by 4 yards, not feet. And the area is length times width, so 5 times 4 are just 20 square yards. Okay? 2. Timothy runs every morning once around a circular track in a park close to his house. If the radius of the circular track is 50 yards, how far does Timothy run every morning? Okay, so Timothy's running around a circular track. We're told that the radius is 50 yards. Okay. And we're asked, how far does Timothy run every morning? So as far as circles go on the ASVAB, you need to know two formulas. You need to know the circumference formula, this formula for circumference, namely, and there's two of these formulas. 2 pi r, that is 2 times pi times the radius, are simply pi times diameter. These are equivalent. And you need to know the area formula, which is pi r squared. Okay? The key difference between circumference and area is this. Area refers to all the shaded portion, that is the face of the circle. Okay? Whereas circumference refers to this outer edge of the circle. Imagine if you were to start walking here and you were to walk in a circle. The distance it took you to walk around that circle would be the circumference. And if you think about it that way, it should help you keep them separate in your mind. In this case, we're asked to find out how far he runs around the track every morning. So we're going to be looking for the circumference. We're given the radius, so we're going to use this formula. So let's go ahead and start plugging stuff in. Circumference equals 2 pi. R in this case is 50. Circumference equals 50 times 2 is simply 100 pi. Now, for both of these problems, you can see that you have to address the fact that pi is there. Since you're not allowed to use a calculator, pi is always going to be 3.14. Okay? Again, in many cases, you're going to have to approximate answers like I did in the first problem. So you're going to have to use an approximation of pi, namely 3.14. So let's go ahead and rewrite this with pi. So this is 100 times 3.14. Now you could work this out by doing 100 times 3.14. That's the tedious way to do things when you have a whole number like 100. Instead, this is how you can do it. So whenever you multiply something by 10, 100, or 1,000, you count up the number of zeros. In this case, 100 has 2. And you move the decimal place twice to the right. 1, 2. So in this case, we know the circumference is going to be 314. So that math worked out pretty nicely for us. Again, you could have done this in my previous videos. When I multiply a 3-digit integer by a 3-digit integer, I'm more likely to make mistakes. This is a lot of work. Knowing this shortcut reduces errors and the time it takes you to complete this problem. Number 17. A 12-yard long string was used to enclose a freshly painted flower garden, forming a square around the garden. If each side of the square used the same amount of rope, how long was one side of the square surrounding the garden? So again, we formed a square around the flower garden. All the sides are the same, and we know a 12-yard long string was used. So the perimeter is going to be side plus side plus side plus side. In other words, all the sides are equal since this is a square. And what's more, we know side plus side plus side plus side is going to be 12. That is 1, 2, 3, 4. 4s equals 12. Now we solve for s. Divide both sides by 4. That goes away. We're left with s equals 12 divided by 4, or 3. So we know each of these sides is going to be a distance of 3 yards, which is right there. Okay, number 19. A rectangle is 3 times as long as it is wide. So we got a rectangle. The perimeter of the rectangle is 147 inches. What is the length of the rectangle? So we're told that it is 3 times as long as it is wide. So if it's x wide, it's 3x long. Okay? And that's the length. This is the length. That's the width. This is the width. If the perimeter is 147, what is the length of the rectangle? So again, just like this problem, we're going to do 3x plus 3x plus x plus x. Should be a plus there. Equals 147. Again, to find the perimeter, you add up all the sides, which we've conveniently written as x and 3x. So this becomes 3x, 6x, 7x, 8x. 8x equals 147. Divide both sides by 8 to get x by itself. 147 divided by 8. Does 8 go into 14? It does one time. 14, 1 times 8 is 8. 14 minus 8, of course, is 6. Drop down this 7. Does 8 go into 67? It does 8 times. 8 times 8, of course, is 64. Subtract. 67 minus 64 is 3. Does 8 go into 3? It doesn't. We have to add a 0. Add a decimal when we add a 0. 8 goes into 33 times. 8 times 3, of course, is 24. 30 minus 24 is 6. Okay. Add a 0. Does 8 go into 60? Let's think about that. It does 7 times. So we know we're going to be working with the decimal here. We can round it to 8.4 since we know this 7 is going to kick that 3 up. So we know x is equal to approximately 18.4. We want to find its length. So we're going to take 18.4 and multiply it by 3. Again, we're going to make this a whole number by moving this decimal over 1. We'll add it back in at the end. 4 times 3 is 12 plus 1. 8 times 3 is 24 plus 1 is 25. Add 1. 3 times 1 is 3 plus 1 is 4. Again, bring that decimal back in. So this becomes 45.2, which we can see up here is going to be 45 inches. Okay, 23. A field measures 100 yards by 75 yards. If one person wanted to walk diagonally from one corner of the field to the other corner, how far would she walk? So we know we got a rectangular field that measures 75 by 100. Question is, how far would it take someone to walk from this point to this point, that is diagonally? Well, as you can see, these are all right angles in rectangles. And when you draw a diagonal across a rectangle, you actually split the rectangle into 2 right triangles. Okay? And this is the distance we're after. When you have a right triangle like this, you can use the Pythagorean theorem to find the hypotenuse, which I denoted with the x. Pythagorean theorem is this: a squared plus b squared equals c squared. And again, c squared is the hypotenuse, the distance of the hypotenuse, or the length of the hypotenuse. The hypotenuse is always directly across from the right angle, so the c squared in this case would be right here, the x or the c, however you want to denote it. And we have the 2 distances of our lengths of our legs. So we can plug these in. 75 squared plus 100 squared equals c squared or x squared, whatever you want to put in there. And you might be looking at this and saying, wow, that's a lot of math. 75 times 75, 100 times 100, those are big numbers. Well, before I go any further, I'm going to reduce this all by a factor of 25. I know 25 goes into 75 3 times, and I know 25 goes into 100 4 times. So at the very end of this, instead of dividing c squared by 25, I'm actually going to reverse that and multiply it by 25 to get the actual distance. So this becomes this. 3 squared, of course, is 9. 4 squared is 16. Again, this all equals c squared. 9 plus 16 is 25 equals c squared. Square root both sides to find the answer. C just becomes 5. Now again, I divided both of these by 25 to make this math very simple. Now I'm going to take 5, multiply it by 25 to get the actual distance. 5 times 5 is 25, carry the 2. 5 times 2 is 10, plus 2 is 12. So we know this actual distance is 125 yards. Okay? Again, you have to be pretty comfortable using little tricks like this to make the math easier. You could have worked this out by doing 75 times 75. Again, and you could have done 100 times 100. When you work long multiplication problems out like these, you're apt to make mistakes. As long as you're comfortable reducing and then going ahead and adding and fixing that at the end like I did here, you should be fine. Alright, number 3 is a very good question, unlike number 2. And you will see something like this potentially on the ASVAB. For some reason this OneNote's giving me some issues here, so just bear with me. The sum, number 3, the sum of the measures of the angles of a hexagon is, so to find the sum of the interior angles of any shape, use this formula. 180 n minus 2. 180 times n minus 2, where n is the number of sides in the shape. So if you had a triangle, n would be 1, 2, 3. There are 3 sides in a triangle. If you had a square or rectangle, there was 1, 2, 3, 4 sides, so n would be 4. Hexagon, as you may recall, has 6 sides, so we simply plug in 6 for n and solve accordingly. So we're going to get 180. Again, a hexagon has 6 sides, minus 2. 180. 6 minus 2 is 4. So this becomes 180 times 4. Let's work that off to the side. 0 times 4 is 0. 4 times 8 is 32. Carry the 3. 4 times 1 is 4, plus 3 is 7. So we know 180 times 4 is 720. So we know the sum of the measures of the interior angles of a hexagon is 720 degrees. Again, just a formula that you should commit to memory. Not a hard one to remember either. The perimeter of a rectangle is 90 degrees. So let's draw a rectangle real quick. One side of the rectangle is twice the length of the other. What is the length of the longer side? So perimeter of a square or rectangle is side plus side plus side plus side. In this case, we're told one side is twice as long as the other. So this would be 2s and this would be s. In other words, this is 2 times the length of side s. So this is going to be 2s and this is going to be s because, again, these sides correspond and these sides correspond. Now the new perimeter is going to be s plus 2s plus 2s. Again, just adding up all the sides, albeit with the new conditions I put in. Perimeter is going to be s plus s is 2s, plus 2s is 4s, plus 2s is 6s. We're told the perimeter is 90, so 90 equals 6s. Divide both sides by 6. This crosses out. We're left with s equals 90 over 6. Let's work this out to the side. 6 goes into 9 one time. 6 times 1, of course, is 6. Subtract. 9 minus 6 is 3. Bring down this 0. 6 goes into 30 5 times. 5 times 6 is 30. Subtract, this is 0. So we know S is going to be 15. That means this side's 15, this side's 15. This is 2S. If S is 15, we know this is 30, and this is 30. So in this case, we know the longer side is going to be 30. A farmer constructs a wooden bin. The bin is 6 feet long, 4 feet wide, and 3 feet deep. The bin rests on legs that are 3.5 feet tall to keep grain away from the damp ground. How much grain can the farmer store in his new bin? So a bin is basically a cube. Let me go ahead and sketch one of those out real roughly for you. And if you take a look at our answer here, we're talking about cubic feet, so we know we're going to be working with volume. The volume of a cube or a rectangle is going to be this. Volume equals length times width times height. If it was a cube, it would simply be one side cubed. But since all these sides are different, we do length times width times height. We know it's 6 feet long, 3 feet deep or 3 feet tall, and 4 feet wide. Okay, and we know it's sitting on these legs. That's irrelevant. The information about the legs is extraneous information. So let's go ahead and plug these numbers into our volume equation. We know the length is 6, the volume is, or the width is 4, and the height is 3. Let's keep working that out. This becomes 12 times 6. And in case you don't know your times tables for 12s, let's work that out. 6 times 2 is going to be 12. Carry the 1. 6 times 1 is 6, plus 1 is 72. So the volume is going to be 72 feet cubed, or 72 cubic feet. A rectangle with a square area of 60 square inches is 4 inches longer than it is wide. What is the width of the rectangle? So we got a rectangle, looks something like this. We know the area is 60. How do you find the area of a rectangle? In case you forgot, it's length times its width. In this case, we're given neither of those pieces of information. Instead, we're told that the length is 4 inches longer than the width. I'm going to represent width with an x since it's unknown. Since the length is 4 inches longer, I'm going to make this 4, or x plus 4. Now we can do some math. Let's go ahead and plug these two variables into our area formula. So area equals x times x plus 4. Again, I just plugged that right into this equation. What's more, I know the area is 60, so A is equal to 60. Let's fill that in this next line. Okay. Now I got to distribute this x specifically to here and here. So 60 equals x times x is x squared. X times 4 is 4x. Okay, now we have a quadratic equation. The only way to solve these is via the quadratic formula, graphing, or factoring. The quickest way, as I'm sure you know, is by factoring. So to get it set up to factor, I have to move this 60 over here, so I'm going to have to subtract it from both sides. 60 minus 60 is 0, and we just subtracted it off the end here, so we're left with 0 equals x squared plus 4x minus 60. Okay. To put this in a form you're used to, I'm just going to rewrite it one more time. X squared plus 4x minus 60 equals 0. Now we're going to factor. If you remember how to set that up, it looks like this. To fill in the blanks, which are right here and here, you're saying to yourself, what can I multiply to get negative 60 that adds to positive 4? Again, what can I multiply by each other to get negative 60 but adds to negative 4? Let's do a positive 10 and a negative 6. Again, negative 6 times 10 is negative 60, so it checks out there. 10 plus negative 6 is positive 4, so it checks out there. So these are going to be our two factors. Now we take these and set them to equal to 0 separately. X minus 6 equal to 0. X plus 10 equal to 0. Solve by simply moving this 6 over. X is going to be 6. Solve by moving this 10 over. X equals negative 10. Okay. Since area is in regard to real shapes, we can't have a negative number, so we know this isn't going to be a solution. We know X is going to be 6, so in other words, we know 6 is going to be the width. We know the length is 4 inches longer, so that's got to be 10. The question is, what is the width? 6. Triangle with a perimeter of 60 inches has one side that's twice as long as the shortest side and a third side that's 8 inches longer than the shortest side. What is the length of the shortest side? Okay, so we got some triangle. Doesn't matter what it looks like. We're given all this information about its sides, but we're not told specifically what any one side is in terms of length. But we are told that its perimeter is equal to 60 inches. And to find the perimeter of a triangle, we simply just add up its three sides. That is side plus side plus side. And in that case, that would be side plus side plus side. We can't do that because we don't know what these sides are. So let's go ahead and try to make this into something we can do. I'm going to represent the shortest side as x. And we're told that one side is twice as long as the shortest side. So if the shortest side's x, twice as long as that is going to be 2x. And we're told a third side is 8 inches longer than the shortest side. If the shortest side's x, 8 inches longer than that's going to be x plus 8. Now we can plug things in. Again, perimeter is side plus side plus side. So we have perimeter equals x plus 2x plus x plus 8. We know the perimeter, or P, is equal to 60, so let's plug that in as well. 60 equals x plus 2x plus x plus 8. Combine like terms. 60 equals x plus 2x plus x. X plus 2x is 3x, plus x is 4x. Then we just have that 8 hanging out there. Let's keep reducing. I'm going to subtract 8 from both sides. 8 minus 8 is 0. 60 minus 8 is 52. Still left with this 4x. Divide 4x by 4. What you do to one side, you have to do to the other. This crosses out. We're left with x equals 52 divided by 4. Now we need to reduce that. If you're not good with times tables, you can turn this into long division. 52 divided by 4. 4 goes into 5 one time. 4 times 1 is 4. Subtract. 5 minus 4 is 1. Bring down this 2. 4 goes into 12 3 times. So we know x, which represents this short side, is going to be 13. Your commander orders you to fly a weather balloon at the end of a 500-foot string. Your first sergeant comes out of a nearby building and stands directly under the balloon 300 feet away from you and yells, "How high is the balloon?" Assuming the ground is level, what is the correct answer? Okay, so let's draw a little sketch. Here you are. You're holding a string that's 500 feet long. And we're assuming also that you've let out all the string. here's the end of your little balloon, and the sergeant comes out and he's directly under the balloon. Say here he is, and he's 300 feet according to the problem away from you. How high is the balloon in the air is the question. So again, unknowns I like to represent with x. In other words, how high is that distance x? This, it turns out, forms a right angle with the ground, and we can use the Pythagorean theorem to figure out what x is. Pythagorean theorem is this: a squared, let me go back one, it's not capital A, it's always a squared lowercase plus b squared lowercase equals c squared, where c is the hypotenuse and a and b are the legs of the triangle. The hypotenuse is always the leg that's across from the right angle. So in this case, this would be our c, and then we can label this one a or b. It doesn't matter how we did that. Okay? So let's just plug things in. I'm just going to copy this formula down here again. A squared plus b squared equals c squared. I told you that hypotenuse is always across from the right angle, so we know that's 500. We know a is going to be 300 squared plus b, which we're going to represent as x squared. Rather than doing this difficult math, and again this is squared right there, rather than doing this difficult math, I'm going to simplify things. I'm going to kick off these two zeros and I'm going to kick off these two zeros. It's going to preserve the same proportionality, but it's going to make the math much simpler. So let's go ahead and work this out. 3 squared, 9, plus x squared just becomes x squared. 5 squared is 25. Now we're just solving for x. We're going to subtract 9 from both sides. 9 minus 9 is 0. 25 minus 9 is 16. I'm left with x squared equals 16. To get rid of the squared, we're going to do the opposite, which is square root. That goes away. It becomes x equals the square root of 16, which is plus or minus 4. Think about what we did up here. We took away 2 zeros, so let's add them back in. So x is equal plus or minus 400. Just adding those 2 zeros back in. And could we have a negative value for distance up? No, so we know it's going to be plus 400, which is right here. You have to carpet a room that measures 8 feet by 14 feet. How many square feet of carpet should you buy? Again, we're assuming the room's a rectangle. It's 8 feet wide by 14 feet long. Again, area of a rectangle is length times width. So in this case, it's going to be 14 times 8. Let's go ahead and work that out. 8 times 4 is 32. Bring the 3 up. 8 times 1 is 8 plus 3, 8, 9, 10, 11. So you're going to need 112 square feet of carpet. Igor wants to paint his back patio and front porch. The patio measures 14 by 12 feet and the porch measures 10 by 8. If each can of paint covers 48 square feet, how many cans of paint should Igor buy? So let's say his porch looks like this and his patio looks something like this, or vice versa. We know this one's 14 by 12. This one's 10 by 8. Again, we're looking for area of rectangle, so that's going to be length times width. And specifically, we're going to have to find the area of this shape and add them together. So in other words, we're going to have to do area equals 14 times 12 plus the area of 10 times 8. Let's go ahead and work that out, and then we'll be able to figure out where we need to go from there. So 10 times 8 is just 80. 14 times 12, we'll have to work out. 2 times 4 is 8. 2 times 1 is 2. Bring down to 0 since you're starting a new row. 4 times 1 is 4. 1 times 1 is 1. Add. 8 plus 0 is 8. 2 plus 4 is 6. 1 plus nothing is just 1. So we have 168 plus 80 for the areas of each respective shape. Now we add them together. 0 plus 8 is 8. 6 plus 8 is 14. Carry the 1. 248. So we know the area of the combined spaces is 284 square feet. We know one can of paint covers 48 square feet. So to find out how many cans he needs, we have to divide 248 by 48. 50. Imagine this 48 were 50. 50 times 5 would get us 50, 100, 150, 200, 250. Okay? So let's go ahead and multiply 48 times 5 and see how close that gets us. 5 times 8 is 0, is 40. Carry the 4, 20, 24. So 48 times 5 is 240. Again, 5 cans of paint would only cover 240 square feet. That means we wouldn't be able to paint 8 square feet. So we're going to need at least 6 cans of paint. Find the missing length in a right triangle where the lengths of the two known legs are 10 inches and 24 inches. Okay, we're told it's a right triangle. We're told the legs are 10 and 24 inches respectively. We need to find this measure, the measure of this length for this problem. In the previous problem, I told you that Pythagorean theorem says a squared plus b squared equals c squared, where c squared, which is the length opposite the right angle, is the hypotenuse. So we'll go ahead and call this one a, this one b, plug it in and find c, or x in this case. So a is 10 squared plus b 12 squared equals c squared, which is the unknown length right here, the hypotenuse, which is across from the right angle. 10 squared is 100 plus 12 squared, which is 144, equals c squared. Oh, this is 24, not 12. So let's start over. 10 squared plus 24 squared equals c squared. 100 plus 24 times 24. 4 times 4 is 16. Carry the 1. 4 times 2 is 8. Add the 1. That's 9. Bring down a 0. We're starting a new row. 4 times 2 is 8. 2 times 2 is 4. Let's add 6 plus 0 is 6. 9 plus 8 is 7. Carry the 1. 17. Carry the 1. 576. So this is 576 equals c squared. 100 plus 576 is 676 equals c squared. To get rid of the squared, we take the square root of both sides. We're left with c equals the square root of 676. So we know it's going to be a whole number. Instead of doing, since I'm not very good with squares, let's just multiply this. We know 20 squared is 400, so we know that's too big. 30 squared is going to be 900, so that's too big. Let's go ahead and square 26 and see if that gets us that number. 6 times 6 is 36. Carry the 3. 6 times 2 is 12. Plus 3 is 15. Bring down a 0. 2 times 6 is 12. Carry the 1. 4, 5. 6 plus 0 is 6. 5 plus 2 is 7. 5 plus 1 is 6. So we know it's going to be 26 inches. Konnichiwa.